Dear students, in this video we are going to learn the computer representation of graphs. A graph can be represented in the form of a matrix. So in computer science, graphs are typically represented using a matrix which is called as the adjacency matrix. So let us know what is an adjacency matrix. An adjacency matrix of G of order n is an n cross n matrix where the matrix A is the set of elements Aij. It is the array of elements Aij where Aij takes the value 1 if Vi Vj is an edge of the edge set E of G and it takes the value 0 otherwise. We have another matrix which is called as the incidence matrix. The incidence matrix of G is an n cross m matrix which is B equal to the array of elements Bij where Bij takes the value 1 if Vi is incident with the edge Ej and 0 otherwise. So let us understand this with this example. Consider the graph G. So we'll find the adjacency matrix and the incidence matrix of this graph G. So we see here this graph G consists of the vertices V1, V2, V3, V4 and V5. Now this graph G consists of the edges E1, E2, E3, E4, E5 and E6. So now adjacency matrix A is a n cross n matrix. Since you have the graph with 5 vertices, so your adjacency matrix will be of order 5 cross 5, right? So for our understanding, we shall write the vertices in an order along the row as well as along the column in the same order. So V1, V2, V3, V4, V5, the columns are also labeled as the V1, V2, V3, V4, V5. Now in the graph, is there an edge connecting V1 and V1? That means there is no loop connecting V1 and V1. So that it takes the value V1 takes the value 0. Is there an edge V1, V2 in the graph? Yes, V1, V2 we have. Edge E1 is the edge connecting V1 and V2. So it takes the value 1. V1, V3. There is an edge E2 connecting V1 and V3. So the value is 1. V1, V4. We have an edge E6 connecting V1, V4. Hence it takes the value 1. Then V1, V5. There is no edge connecting V1 and V5. Hence the value is 0. Similarly, V2. V2 is connected to V1 through the edge E1 and hence the value is 1. There is no loop at the vertex V2. Hence V2 is 0. V2, V3. We don't have any edge between V2 and V3. Hence it is 0. V2, V3 is 0. Then if you consider V2, V4, it is 1. V2, V5. V2, V5 is 0 because no edge connecting V2 and V5. Similarly, V3, V1 is 1. V3, V2 is 0. V3, V3 is 0. V3, V4 is 1. V3, V5 is 0. Similarly, we can write for V4 with the other vertices, rest of the vertices, and the adjacency of V5 with all the other vertices. So such a matrix, resulting matrix is called as the adjacency matrix of the graph G. So you can see that in the first row there are 3 ones, which means the degree of vertex V1 is 3. In the second row, the vertex, there are 2 ones, hence the degree of V2 is 2. Similarly, V3 degree is 2, V4 degree is 3 and degree is 4. There are 4 ones. then V5 the degree is 1. So these are the informations that you get from the adjacency matrix. Now let us consider the incidence matrix. So incidence matrix is a rectangular matrix of order n cross m. N is the order of the graph, that is number of vertices present, and m is the number of edges present. So here there are 5 vertices and 6 edges, and therefore it is a 5 cross 6 matrix. So we label each row by the vertices and each column by the edges. So V1, V2, V3, V4, V5, E1, E2, E3, E4, E5, E6. Now V1 is V1 is incident to the edges with the edges E1 and E2, E6. I'll repeat, V1 is incident with the edges E1, E2 and E6. So therefore V1 E1, V1 V2 E2, V1 E6 takes the value 1 each. So 1, 1, 1. So there is no incidence of other edges E3, E4, E5 to the vertex V1. Hence it is 0. Similarly, V2, if you consider V2, the edge E1 and E4 are incident with V2. So E1 and E4 with V2 will takes the value 1, rest all 0. Similarly, you can write the rest 3 rows. So this is called the incidence matrix. Incidence matrix.